All right. So let's begin with the easiest part, the simple part. We're going to begin with what is a set, okay? And in mathematics, a set doesn't have a definition. So we can apply characteristics to a set. You can say a set is a group of things or of characteristics that if you define that as a definition, that would be wrong, right? A set doesn't have to be that like that, but it is a characteristic. What it is important though is that you know that every single set is denoted with the letter A or B or C or every letter in the alphabet but capital letter. So for example, this will be a reference to the set A and this will be a reference to the set B. All right? Cool. So far so good. Now, I could also draw things inside of the circle. Inside of the circle will be things that I say are going to belong to the set A. So my little heart here, a little ball, maybe a square, and a little triangle. Right? So far, my set A has 4 elements. Heart, circle, square, triangle. All right. But you could also write other things. Maybe you can write colors. So for example, in set B, I'm going to say you have blue. There we go. We have red. And I don't know, we have white. So we have 3 colors. All right. The amount of elements in set A is 4. The amount of elements in set B is 3. So far, we have 2 sets and each set with its own elements. Now, there are ways to write a set and its elements using different representations than these drawings. Those are just by writing or listing the elements of the set. So for example, let's go with this. The set A is going to have, if you write it like this, set A have the elements, and you write inside of these brackets, these curly brackets, you're gonna write the elements of the set A. So the set A is gonna have heart, circle, square, triangle. And the way in mathematics we have to kind of separate the elements is by using commas. So don't forget about the commas, right? Like this, you're saying that the set A has 4 elements and those elements are heart, circle, square, triangle. So far, all we have been seeing is how to write sets, all right? Let's do it with B. B is going to be the set of. And again, set of is just this little curly bracket. Again, this curly bracket is read as the set of. So here you have B is the set of blue, red, and white. There we go. All right, cool. Let me ask you a couple of questions. Can you say, and you go ahead and write it in the chat, please. Write yes or no. Can you describe set B? The set B. Can you describe it as the set of the colors? Yes or no in the chat, please. Okay, I'm having a lot of answers today. Beautiful. Thank you, guys. All right. Everybody in the chat said yes. And that would be a mistake. Now, why? Why is that a mistake? One person said no. Thank you. Thank you, Lau. All right. Why would that be a mistake? I said, can you describe B as the set of colors? And even though set B has colors, and even in set A does not have colors, saying that set B is the set of colors means set B has all the colors in it. And that is a mistake because here you don't have yellow, you don't have, I don't know, green, purple. You don't have a lot of colors. You just have 3 colors. 3 specific colors: blue, red, and white. So mathematics and sets, this is sets theory. Sets theory in mathematics is extremely dependent on the description you give to each set. It is extremely dependent on that. You want to be good at this, you need to write down the perfect description for a set. Question to you guys. Okay, everybody in the chat, please write yes or write no. Can you describe set B as the set of these 3 colors? As the set of 3 colors? Can you describe set B as the set of 3 colors? Yes or no in the chat. All right, let's see. Okay, now we're having mixed answers. Some people are saying no, some people are saying yes. Congratulations, guys. Pretty good. Now, let's think about the description I gave to set B. I said set B is the set of 3 colors, and that is correct. But that is a characteristic, a property if you might. But that is not the entire description of the set, because this set doesn't only have just 3 colors, it has 3 specific colors. It has blue, red, and white. If I describe set B as the set of 3 colors, set B could also be this one: red, blue, blue, and black. And like that, this set also has 3 colors. So if I describe set B as the set of 3 colors, these 2 are set B. And that is a mistake because they don't have the same elements. All right? Again, in set theory, you have to be extremely and perfect descriptive about each set. All right? The success of set theory comes from being perfectly descriptive of each individual set. Question 3 in the chat, please. Can you describe set A? Set A now. Set A as the set of heart, circle, square, and triangle? Yes or no, please. Beautiful, thank you. Let's read the answers now. Okay, I have a lot of yes, and I have 2 no's. No, just 1 no. Okay. Well, the people who said yes, congratulations. You are right now, because I just described the set A perfectly. Set A only has 4 elements, and I named those elements perfectly: heart, circle, square, triangle. That's it. Now, of course, I could be a little bit more specific if I say, for example, the dimensions of every single one of those elements. I don't know, maybe the area, or maybe the surface area. I don't know. Maybe the length and the width. I don't know. I could be more specific, but we don't have those elements. We don't have those dimensions and those measurements in here. So I am describing the set A as perfect as I can from the elements of set A. If I describe set B as the set with 3 colors, blue, red, and white, I am describing set B perfectly, which is exactly what we did here with set A and here with set B. Writing down the elements of a set is the best possible way. Again, the best the absolutely best possible way of describing a set. So from now on, if you want to describe a set, all you have to do is list its elements and you are good to go. I assure you, you can probably write down the characteristics of a set and that would give you some amount of success. But if you write down every single element, you're good to go. There is no way you can have a mistake. Beautiful. From here, let's continue with what does it mean for a set to be equal to another. In the chat, do you guys think set A and set B are equal? Yes or no? Beautiful. I have a lot of no's now. Congratulations. Okay, the question is, you might say, is that a trick question, teacher? Because that it looks to me like they're not the same. I mean, this one has these elements and this one has this color. So come on, they're not the same. And you would be right. But what would you say about B and this one? Let's say this is set C. What would you say about set B and set C? Look at this. It has one element in common and it also has another element in common. Are these two sets the same? Yes or no? Guys, in the chat, please. There we go. Somebody's answering now. Yes. Okay, the people who's writing no, thank you. Thank you. Thank you for writing no. And I mean, yes, those two sets are not the same. So thank you for writing that. Go ahead and write down why not. What is the difference between those two sets? What is that something that makes them not the same? Write it in the chat, please. Okay, two people are answering now. 3 people, beautiful. There we go. Okay, cool. Thank you guys, appreciate it. And all of you will be right. Set B and set C, even though they have 3 colors each, and blue are in the 2 sets, and red is in the 2 sets, they do not have the same colors. One is white, one has white, and the other one has black. So they don't have the same colors. What if I do this now? Instead of black, I'm gonna write down white. But there is a difficulty though. Look at this. The first element is blue, but in here the first element is red. Set B, the second element is red, and in set C, the second element is blue. So I switch those two. Are those two sets the same now? And the answer will be yes. In mathematics, in set theory, which is what we are studying, remember, everything that has to be related with sets is called in mathematics set theory. So in set theory, we call 2 sets the same when each and every one of its elements are the same. And we write it like this. We say B is equal to C. And that makes sense. We are saying that the set B has the same elements to set C. These two are the same set. Order does not matter when we talk about sets, guys. All right? Hopefully you're writing somewhere. You're writing these things down because this is pure gold. All right. Congratulations. So far we know what is a set, or kind of know what is a set, how to write down a set and its characteristics, and we know how to differentiate sets. When are they the same and when they are not the same. If 2 sets are not the same, you write it like this. For example, A and B are not the same set. Makes sense. A has different sets, different elements than B. A and B are not the same. So in mathematics, when you want to say no, you scratch with a line. That's what you do. You say no, no, no. All right, let's continue. Let me erase here a white. If I do this now, if I erase the white, the element white in set C, I have to go like this. These two are not the same, right? Because this one has 3 elements, this one has 2 elements. So of course they are not the same. All right, let's continue. But these two share a characteristic. This one has the element blue, and this one has the element blue as well. This one has the element red, and this one has the element red as well. Of course, this one is missing the white, but B and C have some characteristic. B and C have some elements in common. So how do you write that? How do you write B and C have some elements in common? You call that a subset. A set between or in the middle of another set. A set that belongs to another one. And this is how you write it. Set C is contained in the set B. This is how you write it. And it makes sense. This little symbol here, it can be read in 2 different ways. As I said, it can be read as is contained. So C, the set C is contained on the set B. That is how you read it. Or you can also read it as the set C is a subset of set B. Again, 2 ways of reading this. Is contained or is a subset. Nonetheless, it means the same. It means that all the elements in set C belong to set B. And in this case, that is right. Look at this. The set red, the element red belongs to the set B. And the element blue belongs to the set B. So you can write down that characteristic like that. Set C belongs to the set B. Or the set C is a subset of a set B. But in order for that to happen, every single element in this set, in the set C, has to belong to the other one. Every single one. So if I go like this, if I say red, blue, and heart, red, blue, and heart, then this characteristic can no longer be applied. And I have to say, scratch it. Set C is not a subset of B. Set C is not contained, not on set B. All right, beautiful. But what if I go like this now? What if I go like this? Look at this. What if I erase set the element white in set B? Okay, now we know. If we have been paying attention, we know for sure. Set B and set C, B and C, have the same elements. So that makes it so that those 2 sets are the same. And I could write an equal here, right? But look at this. I could also write the subset sign. I could also write that. And why? Okay, because of this. The set C is contained in the set B. Every single element in the set C, belongs to the set B. Did you look at? Are you looking at this? Man, math are beautiful now, because now we can describe equality. Now we can describe an equality of 2 sets using only the subset sign. And that is powerful. Now you can say this, but you could also say it backwards. You could also say that the set B and the set C have a characteristic. Set B is contained in the set C. You can also say it like this. And you will be right. Because every element in the set B is contained in the set C. This set is contained in C. All right. Some books write this expression backwards sometimes. Now, I don't think we're going to look at this in the books of the IB in mathematical studies. I don't think we're going to look at this ever. But just in case you're interested in this, this is called a superset. B is a superset of C. Superset. Ooh, what is that, man? I don't know. Don't get scared. Is the absolutely same. You just read it backwards. C is contained in B. Or B is a superset of C. You just read it backwards. It is the same, all right? But like I said, for mathematical studies, let's focus on this sign. Beautiful. I think with this, you can now go and begin doing exercise 2 from the PDF I sent you, all right, guys? Now, I'm going to be here answering any question, but in that PDF, I need you to go around your room and go around your house and look for things, right? This is going to be kind of a scavenger hunt, but not really, but kind of. So go ahead and read the exercise, guys, and if you have any questions, ask me. Thank you. I did not mean to do that. There, stop recording.